Hello, welcome to Special Relativity, a video about special relativity. Special relativity was one of Einstein's theories. Einstein was born in Germany in 1879, the same year that milk was first sold in glass bottles. He was very good at playing his violin, which he named Lena. He also offered the job of President of Israel, but he declined that offer. They say that Einstein was very against socks and haircuts, and also that he was the inspiration for what Yoda looks like. But then some people will say anything. Einstein won the 1921 Nobel Prize for Physics, although he had to use his prize money for a divorce settlement. The Nobel Prize wasn't actually for his work on special relativity, but it was pretty great anyway. A part of special relativity that's very important to understand is how light behaves. The universe has no stationary point. Everything can only be measured relative to everything else. For example, if Phil and Patrice are running towards each other, they could be described as having v velocity each. However, from the point of view of Patrice, Phil has 2v velocity. Likewise, if Phil is chasing Patrice in a car travelling at 5v, and Patrice can only run away at a speed of v, the car is relatively travelling at 4v, and Patrice is likely to be run over pretty soon. The strange thing about light is that it appears to move at the same speed, whatever frame of reference you're viewing it at. Light travels at 300 million metres per second. This we are sure of. Einstein was famous for his thought experiments, and he came up with a great one for special relativity. Imagine a clock which measures time by measuring how long light takes to bounce between two mirrors. That would be a very accurate clock. However, as soon as the clock starts moving, the light has to travel further distance than when it was still. This is shown in our diagram. The light has to travel further when the clock is moving, so it will take longer. This means that time actually slows down. The amount which it slows, Einstein called the time dilation factor, and he came up with a lovely equation to work it out. The time dilation equals the time divided by the square root of 1 minus the clock's speed divided by the speed of light. One of the most important ways this is used is in sat-nav systems, because time on a satellite orbiting the Earth passes at a different rate to us. Scientists have worked out that if they ignored the time dilation, sat-navs would be off by about 10 kilometers. Lucky Einstein thought of it, really.